Hey guys, this video will cover an introduction to chemistry. Now, through the course of this unit, we're going to look at things starting at the very small and then moving up to a little bit larger. And so it's important to understand all the specifics, all the small details of the microscopic or atomic level items. And that's what this video and then 3 activities within this particular set of information will cover. So we're going to start with the smallest thing, and this is the atom. And it's something that you've probably seen before, and it's pretty popular in terms of advertising and marketing. But in all reality, it's a fair representation of everything that you need to know. Now, an atom is made up of 3 different things. Now, and each of those things serve a different purpose. So the most common thing people see are these little circles flying around the outside. And so these are called electrons. And electrons are something that move in what's called an electron cloud around the nucleus. And the unique thing about electrons are 2 things. They are negatively charged, and they also do not have much weight, almost no weight at all. And that's going to be important when we talk about atomic mass of elements. So electrons fly around the outside of the nucleus, carry a negative charge, and have almost no weight. Now, we move to the inside. The inside, which is this area here, is called the nucleus. And there's 2 different things in the nucleus. The first thing is a proton. Now, a proton is the opposite of an electron in that it carries a positive charge. Now, this is important to remember because atoms are most times neutral. And what that means is their charge is equal to each other. So for every negative, you also have a positive. And this means that protons and electrons are normally equal to each other in a neutral atom. They're represented in blue in this particular, I'm sorry, they're actually represented in red. So I'm gonna change this. And you might be asking, Mr. Julian, how do you know? If you count the number of red circles, you'll see that there are 3 of them. However, if you count the number of blue circles, there's 4 of them. And from what I just told you, the number of protons have to equal the number of electrons. So if I have 1, 2, 3 electrons, I also have to have 3 protons. So the protons in this case are red. So I'll rewrite that. Protons, and they are positive. Now, a difference between these electrons and protons are that protons have significantly more weight. And that's important in terms of us calculating the total number of each individual part. So now we're back to these blue dots. And in this case, the blue dots, and there's 4 of them, are neutrons. Now, if we have a neutral atom, and I told you that the electrons and protons are equal to each other, this means that neutrons can't carry a charge, and so they are actually no charge or neutral charge. And that'll be important when we talk about these idea of isotopes. Isotopes are the same element but a different number of neutrons, and it causes just some slight differences in terms of how they interact with other atoms and elements. Now, neutrons also have a significant amount of weight, and in fact, a neutron is pretty much the same individual weight as a proton. And so we know that electrons have almost no weight, protons have weight, neutrons have weight, and the weight of a proton and a neutron are just about the same. All right, so the question is, how do we link up these idea of atoms to elements? And I'd like to direct you down here to the periodic table of elements. So now the question is, what in the world is an element? An element is the most fundamental, unique thing you can have. And you might be saying, but didn't you just say atoms make up elements? That is correct, but atoms have the same 3 parts all the time. There's protons, neutrons, and electrons, regardless of what element. The combination of protons, electrons, and neutrons make up elements. So elements are the smallest unique thing that you can have. So when you look at the periodic table, and we'll investigate that further in future videos, we know that each one of these things, each one of these boxes is an element. And each of these things, whether they're over here or way over here, have a different combination of protons, neutrons, and electrons. What this ultimately will mean is that they have different properties, and so they'll react differently, they'll look differently, they'll react with different things. So each of those unique characteristics in terms of the number of protons, electrons, and neutrons mean each of these elements are different. So once again, elements are the smallest unique thing that you can have. So when you're talking about like water, we know water is H2O. That is a combination of two elements. So water is not an element. We'll later see that be identified as a compound or a formation or a molecule that is made up of two elements. But you can't break elements down into anything else. Carbon, you can't break that down into anything else except for its combination of protons, electrons, and neutrons. All right, so let's talk about this, carbon. Let's talk about a specific element and maybe how you can determine some of the characteristics. So within your first activity, you'll have to identify the number of protons, electrons, and neutrons in the first 20 elements. And there's a couple reasons for this. Not only will you get good at calculating those numbers, we'll also use that information to establish patterns. But when you look at an element, you'll see that there's some unique characteristics or information provided on the periodic table. So we see here we have the element carbon. So the first thing we see here is the element name. Now that's important because when we start to talk about symbols, symbols are not always an identical match or as intuitive as you would assume in terms of the lettering for a particular thing. And so a lot of times they're based on Latin. Now, that's traditional for most of the earlier elements. Sometimes it changes a little bit based upon new discoveries, because if you find the element, you get to name it. And sometimes it doesn't always go with the traditional naming mechanism. But so at the top, you'll have the carbon name. It may not always be at the top depending upon the periodic table you're using, but it should be on there somewhere. The next thing you'll have here is the symbol. And like I just talked about, the symbol might not be as intuitive as you want. Like for example, potassium has the symbol K. So don't worry too much about that. You will not need to memorize them. You'll have a periodic table available to you whenever there are questions that warrant that. So you don't have to memorize names and symbols and all those types of things. The other information that we have on here, there's two numbers. So this 6 is what's called the atomic number. And those are always whole numbers. And so for on our periodic table, it would be 1 through 118. No decimals, no fractions, whole numbers. The other thing you have here, which is normally a decimal number, is the atomic mass. And sometimes it's referenced as atomic weight. We know the difference between mass and weight, but for the purposes of chemistry, atomic mass or atomic weight will kind of be, synonymous or the same for this particular unit. Now, let's talk about how this relates to protons, electrons, and neutrons. There's some the atomic number is not just randomly generated. So the atomic number is equal to the number of electrons, and that's super important for you to know. That will help you when you're determining some of those values. The other thing that you need to know is the atomic mass is representative of the total weight, and we know that weight is only influenced by two of the three parts of an atom. We know that that is mostly protons plus neutrons, and then electrons, they still have a little weight, but not that much. So if you were looking at this number, the 12 is most closely associated with the protons and neutrons, and then the electrons kind of make up this little decimal number over here. So now I know I didn't show you how to calculate each one of those individually, but using these rules, the atomic number equaling the number of electrons and the atomic mass equaling protons plus neutrons plus electrons, I'm going to get you most of the way there. So within our activity, you'll be asked to work through the calculations of some of these, and then we'll use that information later on in the or in some later lessons.